Hello everyone. This moment I want to share you something regarding how to solve some question in physics. Actually, this is the part 2 after we uploading of the part 1. Yeah. The part 1 only two numbers 1 and 2, and this is the continue one. Yeah, start from number 3. Yeah, hopefully all the question are finished. Yeah. Okay, we start from number 1. But before we continue about our video, please don't forget to subscribe, like, or comment, or anything like share with your others. Okay, we'll start from number 1. State Newton first law. The Newton first law is talking about how total force equals to zero. Yes, total force equals to zero. Why? This is in at the condition when on the rest or on the constant speed. Yeah, the total force equals to zero. Okay, we continue about number B question. A log of mass 450 kg is pulled up a slope by a wire attached to a motor as shown in the figure 3.1. The angle that the slope makes with the horizontal is 12 degree. The frictional force acting on the log is 650 Newton. The log travels with constant velocity. Okay. With reference the motion of the log, discover whether the log is equilibrium. Yes, because the motor state as the constant velocity. Yes. At the constant velocity, yeah. So, as I mentioned before, if the object on the constant velocity, that's mean total force equal to zero. Zero. It's mean also it's equals with it's in equilibrium. Yeah. If this object has constant velocity, there are no acceleration. Yeah, there are no acceleration because the difference between velocity is zero. Yes, if the constant delta v equals to zero, so as we know, acceleration is delta v over delta t. Zero over delta t is come to zero. So when the equilibrium is when acceleration become zero. And the next question is calculate the tension in the wire. Okay. Totally when we see on this log, yeah, they have weight equals to mg, and they have also about force on the parallel with slope. There are mg sine 12 degree, and they have mg cos 12 degree. So when the motion on the constant velocity, they have total tension drop on this wire equals to mg sine 12 degree. So we can say this is about t equals to mg sine 12 degree. So if we calculate mg, the sorry, we have about the frictional force here. This is minus frictional force. Yes. So we have mass 450 kilogram, and the gravitational action is 9.81, and sine 12 degree minus frictional force we have 650 Newton. So we will calculate this number. For 5O times with 9.81 times sine 12 degree, yes, equals with 917.82. So we minus frictional force equals to 650 Newton. So we have, yes, those they have 267.83 Newton. Yeah, this 267.83 Newton. So the question II state to explain whether the gain in the potential energy per unit of load is equal with output power the motor. Yes, because this is how to gain up the load with the motor. So this is all the potential energy per unit times the same thing with the power of the motor. So because the power of the motor is totally used for bring it up the load into the point something. Yes, the total energy uh, over time on the log, this is equals with power by engine in the motor. So if we continue about other numbers, yes, the numbers 4 is about the electric circuit. We're talking about the LDR or light dependent resistor. A battery of electromotive force 12 volt and negligible internal resistance is connected to two resistor and light dependent resistor or LDR as shown in the figure 4.1. Yes, this is electromotive force here about 12 volt, and we have two resistor 8 kilo ohm and 12 kilo ohm, and the 12 kilo ohm connected parallel with LDR. So let's see about the question. An ammeter is connected in series with the battery. The LDR switches are connected across the point XY. The switch is open. Now question A. The switch is open. Calculate the potential difference between potential difference PD across XY. So we can say this is about the Ohm's law. Yeah, if we calculate the about current I is V over R. V we have 12 volt and R is we have 8 plus 12 in kilo ohm. So we have this is around 12 divided by 20 times 10 minus 3 ampere. And about the potential difference between XY, V on XY, this is equal IR XY. So I equals to 12 divided by 20 times 10 minus 3, and R equals on the XY is 12 kilo ohm or 10 power 3. So we can cancel this one, and this is equal to 144 divided by 20, yes, around 7.2 volt. Okay, we get the potential difference between across XY. Now question B is the switch is closed. The resistance of LDR is 4.0 kilo ohms. Calculate the current in the ammeter. So start from we calculate about the resistance parallel in this graph. Yeah, we need to find this resistance parallel on this. Yeah, so we have about R parallel. It's mean 12 kilo ohm times with 4 kilo ohm and 12 plus 4. Yeah, this is around we calculate plus 12 times 4 divided by yes, divided by 16. Yes, we have 3 3 kilo ohms. So total resistance equals with 8.0 kilo ohm plus 3.0 kilo ohm, so we have 11.0 kilo ohms. So what about the ammeter reading? This is about current equals to V over R. So we have V is 12 volt, and we have this is 11.0 kilo ohms. It's mean times 10 power 3. So we have this is around 12 divided by 11. So we have 1. Yes, 1.1, around 1.1. So 1. This is 1.09 minus 3. Yeah, 1.09 minus 3 ampere, or actually this is 1.09 milliampere. Okay, continue to the next question. The next question on C question is the switch S remains closed. The intensity of light earlier increase. Yeah. State and explain the change into. Okay. The intensity of light LDR, when the intensity of light on the LDR is increased, it means the LDR resistance will be increased also. It mean resistance of the LDR it will decrease. Yeah. When resistance on LDR it will be decreased. Okay. So this is make the ammeter reading because the resistance is decreased, so the total resistance it will be on the parallel one, it will be decreases also, so totally decrease. The ammeter reading it will be decreases also. So what about potential different across XY? Potential different XY because the resistance of the decreases and total resistance of the parallel circuit it will be decreased also. The potential difference on the this is PD on the XY circuit it will be, so LDR decrease make the ammeter reading decreases, so the potential on the XY it will be increases. This is by from the V equals to IR from Ohm's law. Okay, now what about the number 5? To find Young modulus. The Young modulus, actually this is about the ratio of stress. Stress equals to force over area and strain. Strain is extension length divided by initial length. Okay. Okay, continue to B question. This is about graph. A load F is suspended from fixed point by steel wire. The variation with extension X of F for the wire is shown figure 5.1. State two quantities other than the gradient of the graph figure 5.1 that are required in order to determine the Young modulus of steel. Okay, state two quantities other than gradient. So we have about gradient is mean F force divided by extension length. So we can say this is about the force in Newton and extension length in meter. Sorry. State the quantities other than gradient, the graph figure 5.1 that are required in order to determine the Young modulus. This is about force here, and about the extension length. Force in Newton and extension length in meter. Okay. Describe how two quantities used list in one may be measured. This is a force because this is force. We may measure this from the Newton meter. For the force, we can use Newton meter, and for the extension length, we can use a ruler or meter ruler. Okay. Now the third question. A load 3.0 Newton is applied to the wire. Use figure 5.1 calculate the energy stored in the wire. So we have about 3.0 Newton is a load. Calculate the energy stored. The energy means as or half K delta X square, or this is mg over delta X square. So we can say this is about we can cancel this one, so this is same thing with all half mg delta X, or half 3.0 Newton, and delta X we can see here. This is around 0.25. So we can calculate this one by this calculator. A half times with 3 times again with 0.25, it's become a half times with 3 and times again with 0.25, it's become 0.375 joule. Okay, the last question I think. Before we continue again, don't forget to subscribe my YouTube channel, like, comment, or share to others. Question C. A copper wire has the same original dimension. As the steel wire. The Young modulus of for steel is 2.2 times 10 power 11 Newton meter minus 2, and copper is 1.1 10 power 11 Newton meter minus 2. On figure 5.1, sketch the variation X of F of copper wire extension up to 0.25 millimeter The copper wire is not extended beyond its limit of proportionally. Okay, we have about the 1.1 and 2.2. This is also, if we see, the steel is 2 times width for the copper. Yeah, still 2.2 and the copper is 1.1, and this is 2 times with this one. So actually we can say, if we go here, yeah. So F delta x until here we have, for the steel and copper. We can say this one first. Yeah, steel we have 2.2 times power 11, and copper 1.1 times 11. So I think okay, if we calculate 2.2, 2.2 times with 0.25 here. This is around, okay, I think 5.5. Let's say here, and this is, and 1.1 times 0.25, 2.75. Yes, I think around here, 2 point, yeah. Yes, I think this one, yeah. This is about the steel and this is about copper. Yes, this is about steel and this is about copper. Okay, I think enough for this session. Thank you very much for your watching my video. Don't forget to subscribe, like, comment, or share to others. Thank you very much. Bye.